So 1.2 is a review of exponents and powers. And we'll start out with example 1 about reading and writing powers. Express the meaning of the power in words and then with numbers or variables. So as we read our first expression, it says 10 to the first. That's how we would say it in words. And we would use this, I'll use this time as a review. The base of this is 10 and the exponent is 1. The way that exponents work is that you will take the base power of 10 and multiply it by itself as many times as the exponent says. So for 10 to the first, we would simply have 10. Now usually we don't write to the first, it's just simply implied. Okay, that doesn't look very good, but we're going to leave that. Okay, our next one then is 4. You'll see that the exponent is 2, but we express that by the word squared, 4 squared. So if we were going to find the value, it would be 4 times 4, which equals 16. Okay, the next one we have is 5, and the exponent is 3. When we have 3, think of a three-dimensional object, which could be a cube, and so we would read that expression as 5 cubed. That would be 5 times 5 times 5, which would give us a total of 125. 5 times 5 is 25, times another 5 gives me 125. Our next expression is 7 to the 6th power. That would be 7 times 7 times 7 times 7 times 7 times 7. You can do that on your calculator. You can also use the exponent button on your calculator. And then our last expression is x to the nth power. We would say nth power for that one, using that th. And so that would be our base of x would be multiplied as many times as the n value. And so that one we don't know. It would be x times x times x times x times x, whatever the value would be for n. Okay, our next example, example 2, says we're going to evaluate the powers. Whenever we see that word evaluate, we usually see the word when, and so that gives us some value to be able to substitute in. So we want to know what x cubed is when x is 5, and that was on the first page. However, I have a little bit more room to write here. So we have 5 cubed. 5 cubed would be 5 times 5. Oh, took me off of my pen. 5 times 5, which is 25. And then we're going to multiply it by 5 one more time. So 25 times 5 will give me 125. Moving on, this time we have grouping symbols, and we need to remember our please excuse my dear Aunt Sally. So for problems that have more than one operation, it's important to know which operation to do first. Grouping symbols, such as parentheses or brackets, indicate the order in which the operation should be performed. Operations within the innermost set of grouping symbols are done first. For instance, the value of the expression 3 times 4 plus 7 is not the same as the value of the expression 3 times the quantity 4 plus 7. I'm going to go ahead and work those out quickly so you can see the difference. So we have a grouping symbol in this first one here, 3 times 4 plus 7. So I would do the grouping first. So the 3 times 4 is going to be 12. And then I'm going to add my 7 to the 12. So 12 plus 7 is going to be 19. Okay, when I look at the next one, simply the same numbers, but they are using different grouping symbols. I see my grouping tells me to add the 4 plus 7 first. So that in our grouping symbol, 4 plus 7 equals 11. And then I'm going to multiply that by the 3. My pen will write my 3. So 3 times 11 is going to give me 33. So you can see a big difference in the answers there, 19 and 33. So when we evaluate an exponential expression, again, evaluate, so you see your word when, means we're going to do some substituting. So we're going to use the same variables, but different grouping symbols. In the first one, we're going to do A plus B is in the grouping symbol. So that would be 1 plus 2. See if it'll be nice and write nicely for us here. So 1 plus 2. Sorry, that's not very legible. And 1 plus 2, and then we're going to square that value. So 1 plus 2 equals 3, and 3 squared would give me my total of 9. Now in the next one, our grouping symbols are around each one of the variables. So we have a squared plus b squared. So in this one, we would have 1, and we're going to square it, plus 2 squared. And we're going to, so both of those are squared. 1 squared would be 1 times 1, which is 1. And 2 squared would be 2 times 2. Sorry, I shouldn't go back and try to fix them. We know that from the years of the Mimeo use. 1 plus 2 times 2 is 4. So my total in this one is going to be 5. 1 plus 4 equals 5. Okay? So exponents and grouping symbols are putting it all together. Here's our word evaluate. Here's our word when, so that's our substitution. 2x cubed. So we have 2 times x cubed. The x cubed doesn't have any grouping symbols, but this is the part that is, oops, didn't do it very accurately. X cubed is a grouping symbol in itself. So for this one, I'm going to have 2 times, my x is 4, and my x is going to be cubed. So 2 times the value of 4 cubed. 4 cubed would be 4 times 4, which is 16, times another 4, which is going to get me to 64. So now I have 2 times 64, because 64 was the value of 4 cubed. So 2 times 64 equals 128. Right? You'll notice in the second one, we're using the same, I'm going to erase that, my black mark there. All right. In the second, we have the same expression, but we have grouping symbols put in there. So when there were no grouping symbols, we go back to our please excuse my dear Aunt Sally. There are no parentheses, so we did our exponent as our first operation. In the second expression, we have 2x in the parentheses, and then we cube it. So we're going to do our parentheses first. So we're going to do 2. We're going to do 2 times 4. And then when we get that, we're going to cube that value. So 2 times 4 is 8. And then we can cube. We did our parentheses first. So 2 times 4 is 8. And 8 cubed would be 8 times 8, which is 64. And 64 times 8 is actually 512. You can do that on your calculator. Otherwise, I'm just following along in the book. So you see the difference between the grouping symbols and how it can change your value or your answer. So we always do a real life application. So exponents are often used in formulas for area and volume. In fact, the words squared and cubed come from the formula for the area of a square is when you multiply one side by another side, or side squared. And the formula for volume is side cubed. Because it's three-dimensional, you have length times width times height. So in example 5, you can see there is a table that we've made, and we're using the same sides or the same edges, 1, 2, 3, 4, 5. Those are the values in inches of each of those sides. If it was a flat object, we would go ahead and just square it, but we are talking about cubes here, so we will cube each one of those values. And that's where you can see the volume values in the bottom row of this table. So using what we just did in the table there, we're going to find the value of a cube, which it happens to be an aquarium. So the aquarium has the shape of a cube, and each edge is 2.5 feet long. you can see how they've shown you that in the diagram. So find the volume in cubic feet. So in cubic feet, we would have to go ahead and we would cube each of the sides, or side cubed. So we're going to go ahead and we're going to say, what they're telling us here is that volume equals the sides cubed. Each side is 2.5, so we're going to say 2.5 cubed. So 2.5 cubed, I'm going to go ahead and I'm going to put that into my calculator. Now again, use some estimation. 2 cubed would be 2 times 2, which is 4, times 2, which is 8. 3 cubed would be 3 times 3, which is 9, times 3 is 27. So when I put 2.5 in my calculator and cubed it, I should come up with a number in between there, which I do. It's 15.625. That was 2.5 times 2.5 times 2.5. Okay, so the volume is going to be 15.625, and that's in cubic feet. See if I can squeeze that in there. Whoops. Kind of sloppy, but 15.625 cubic feet. Now, it then says how many gallons of water will the cubic aquarium hold, and convert the liquid volume where 1 cubic foot holds 7.48 gallons. So we would take all of the cubic feet we have just figured out, 15.625, and we're going to, each one of those is going to hold 7.48 gallons. So that means we can multiply. When you hear the word each, that means multiplication. See if I can make it a little more legible. 7.48. So 15.625 times 7.48, and again, I'm looking in the book. You would just simply plug that into your calculator. Your answer would be 116. I'll tell you, the book is much easier to read if you're ever wondering what this says. 116.875 gallons. I'm going to go ahead and label that as gallons because I just converted it. And that finishes up the review of exponents for 1.2.